question for you. Was Jason born first, or the Jason Bourne movie or the character was created first? Everybody seen the movie? Jason Bourne, the series of movies? What happened first? Sorry?
Character.
The character was built first? Okay. The character was built first, but the movie came later. So any way you answer was done would be good. The character was built in 1980, right? And the first movie, Bourne Identity, came in 2002 or 2004, but the JSON as a data format was created in 2002. So you can imagine whatever happening in technology world, probably there is a mirror of that is happening in the other universe in the movie world too. All right, good, thank you. So we'll talk about the native JSON data type in SQL because it is a first-class citizen. It is no longer a something that is not treated well or something that is not have all the full functionality and all the stuff. And we'll have some new announcements as well. Couple of things. Why JSON is important? It is not just important because there is a Jason Bourne series of movies, but it is important because this is a like universal data transfer standard. Can I get a vote for how many people are from non-English speaking, non-native English speaking countries? A bunch of those, including me, right? So, and when we are speaking here, what language are we using? We are using English. Exactly same thing happens in the application world. An application could have been developed in Java or in Python or in C# or in your favorite language, but when they are talking to each other, they have to talk and transfer communication using something that each other can understand. And for application, what is English for us in this this community? JSON is for applications. So if you care about application, if you deal with application, you cannot ignore JSON. So that's number one, right? Number two, if you're a DBA, if you're an admin, and you use any kind of a third-party tools or any kind of scripting tools, more often than not, you specify your configuration characteristics in a JSON format. For example, if you are creating a resource or an object in cloud, in Azure, and you're using either Azure CLI or some other kind of command line or ARM template or anything, they're all in the form of JSON. So any kind of resource management, any kind of a control, any kind of a capacity management you're doing, you need to specify them as JSON because they are also using the common data format language, which is JSON, right? The other thing that I would call out is actually that if you love to play with data, like not just the data from your business and application, but any data from outside sources. If you want to download the data that are in the Yelp review or in the TripAdvisor review, or if you want to go to, okay, how many people have electric vehicles in my country, right? And those data are already available because governments and various agencies are publishing all those data. And guess what? In what format they publish all these data in? In JSON. Because now that JSON data format can be understood by every program written in any language or database written in any language. And hence, JSON has become a very common part of a developer or DBA's life. And therefore, we cannot just avoid learning it. Can I take a vote? How many of you will call yourself as developer? Oh, fantastic. And how many of you yourself will call yourself as a DBA? A few, good. How many of you call yourself as a data engineer? Okay, good. So that means we have audience full of people who either deal with JSON every single day or want to deal with JSON every single day in every walk of life, and they want their favorite database, which is Azure SQL database or SQL Server, treats JSON as a first-class citizen, not unlike anything else. And we will talk about some of the examples today. So JSON is not new to the world of SQL. In 2016, SQL Server 2016, we released first initial capabilities of JSON. At that time, we have been storing JSON as a varchar text. So you would take the input of JSON, we'll just store the JSON in a varchar text, but we allowed a few operations. For example, we allowed a few operations for you to convert the relational data from your tables and send it out as a JSON document, or receive a JSON document from somewhere else, thread it out into relational table rows and columns, and put it into. We allowed that kind of exchanges. And from then, we have moved to create new stuff. With SQL Server 2022, we added a few more constructs and functions. For example, each JSON, because if the JSON is stored as a varchar text, you don't know whether it is a well-formed JSON or not, either a valid JSON object or not. So we provide you this function, each JSON. So you pass a string to it, and it can tell you, yeah, it is JSON or not. If it is JSON, you know that the subsequent processing. If it's not a JSON, you can throw an error. So those kind of functions we provided with SQL Server 2022, as well as Azure SQL database in the cloud. In what we have now, for several months now, we have native JSON data type available in Azure SQL database in private preview, which means you can sign up for it. We can enable your server and your subscription, and you'll be able to play with it, do all kind of experiment and it done, and then give us feedback. And soon it will be a public preview in the cloud, and when the next version of SQL Server we release, we'll put it there. And honestly speaking, that was exactly the conversation I was having with my boss, and that was I got a couple of minutes delayed because we were talking about what comes in the SQL Server vNext, and we want to make sure that this is on the path to that. So that's how our plan is. Right now it is in private preview, only available in the cloud, but it will be available in other forms as well. The few things to know. So how we do now in a native JSON data type, it's not stored as a varchar or character. It is stored in the binary format. The binary format allows you to do lots of optimization. For example, if I want to read a particular component from the JSON, I don't have to parse it over and over again. Once parsed, I can know where it is and what it is. And for example, we can do update in place. I don't have to read the whole JSON string, update the string, and update that. The longer object I update, you all are SQL people or database people, you know the long, it becomes a heavier workload on the database. But with the binary format, I can update only the component, only the particular field that I want to. The thing is that this, the private preview now supports a JSON document up to 2 GB. It's a pretty decent, pretty good size compared to some of our computers that you can see. They are nowhere in the vicinity of supporting such a big JSON document. So these are some of the characteristics of our implementation. Best to probably take a few examples. One of the examples that we will show you here is that if you want to, so every SQL database has tables, rows and columns. Now, I gave you an example that applications, you are exchanging data with another application, and they want only the language of JSON. So you need to kind of prepare a JSON formatted data and send it out, right? And so we have the capabilities where you can actually query the data, format the object into a JSON format, and then send it out. We'll see in a demo, so that will become much clearer. This is another example where JSON is very importantly used, is because if anytime you're integrating with any APIs, for example, one of the popular things all of us are playing with today, calling OpenAI. Now, if I want to call OpenAI has exposed REST endpoints for a database to call. If you saw in the demo yesterday, in the keynote, Mosma was doing the demo. And then later on, we also had another session on AI. which means that you can call OpenAI or any other AI service from within SQL database through a REST endpoint call. And when you're calling, you'll actually pass on all your ask, like your inputs and your response in the form of a JSON. And so therefore, it is super, super important to send the JSON as a payload, receive JSON as a response, because when you call OpenAI or AI search or any other kind of REST API, you receive response in form of JSON. And whether you're calling it Azure functions, because it's a very popular feature today for calling an Azure function from anywhere, and then you do your work done. Cognitive search, for example, if you're trying to do, if you got a text from somewhere, and you want to find out, do I have a PII data in that? If it is PII data, you want to mask it. You don't want to expose it in the output or on your web page. You want to use cognitive search to find out, does my text has any PII data? Because it has got the PII filtering and all this process. So you'll send your input to Azure Cognitive Search as a JSON. Response will come back as a JSON. So it's super, super important for this integration. And it is showing you the life cycle, basically. So we'll see a few demo and then try to learn how this functionality is working. So what I have here is basically just creating to, is it visible to everybody? Okay, good. Thank you. Sorry about the resolution. So we're creating a table, and if you see that we're calling out as a JSON as a data type at the top. And a field has a JSON data type, and then we're going to actually get I'm getting a value in JSON format, and we're going to directly insert into the table, which is storing this. And then, as you can see, it is storing them as a JSON document. So the database is storing JSON documents as JSON documents. So you can, when you select from it, you'll see a JSON document. But what if somebody wants to kind of read when you are trying to read it back? The function called JSON value. Through JSON value, you can actually call out that which JSON document and which field you are looking for. It can go do the parse for you and actually bring the value back to you, as you say. Not only that, you can actually, whatever value it, okay, very interesting. JSON is nothing but a string of characters. So when you get anything back from JSON, you are getting actually a string, nothing else. So if it is storing your order ID, or if you're storing your date of birth, or you are storing about the order date, or some numeric quantity, you'll have to convert it into the corresponding type. Then you can use it. Then you can aggregate it, you can compare it, you can do everything. After that, it becomes like any variable of your choice. And that's what this example is doing. So first example was just getting a value. The second example is just is getting value and then doing the casting of it into your data type of your choice. Okay, so the next what we're going to show you is the other operations that we can do on JSON type. If you see the difference between the previous table and this table, in this table, the fields are actually called out. The fields are actually called out with their own data type, which means when we receive a JSON document, we are going to thread the JSON document and put their fields in the respective place at the input itself. So we are we could insert the values like this, and we have another table which has got orders information, and we have another table for account information, and we're going to show you how you're going to thread it. Okay, let me see. So slightly different definition of the table compared to previous example, but you can see the difference. And here we are actually passing a JSON variable which consists of multiple JSON documents as an input And in the input time, we're using a function called open.json. It is going to open the JSON document, find out which field is relevant for which field from the JSON is for which column in the table, and then do the insert. And after the insert is done, you can just see that they are all spread out like a normal table without any indication that they came through a JSON document to you. And then you can, of course, do the same operations as you do. So this is the difference between when it was stored as a JSON versus when it's stored as a field. You have both choices. You could do both, depending on what you need, and you can combine them as you need to. Here what we're showing is that you have a relational data, which we just entered into the table, but you have to send it to somebody, and what I was showing on the slide, and this is how you do it through JSON object aggregation. That means you are getting multiple JSON objects, aggregating them into creating a bigger JSON document and sending them as an output. You could do that. This will be if you are communicating with any REST APIs. This is like a daily job. When almost you will not be any of your application development will not be complete without a scenario like this. It's such a common scenario. Any questions? Yes, please. Yeah. Okay. So the question is the native JSON data type will be backported into SQL 2022? No, sir. Sorry to disappoint. Backporting these kind of things is completely kind of extremely difficult, if not impossible, because this is a data type, which means it goes to the very root of the engine. And once we change the version of the engine from the one, you cannot do the back. So it is always forward. We are able to do that in Azure SQL database because it's always up to date. The engine is always up to date. It has got everything from ground up. So these kind of things will not be able to backport to the older version of SQL. Yes, sir, please. Yeah. Okay. So the question is, if you are inserting into a JSON document into a table with a JSON type, but it's not a valid JSON document, will it fail? Yeah, it will fail. We'll give you an error. Okay. So this is also kind of similar type of sorry, yeah. Please. Yeah. So for the repeat of the audience is that we have a function called eJSON. That means you can actually, if you don't want to have that error, you could actually have a different kind of error you can do. Pre-check that the input that you are receiving is JSON, valid JSON or not through eJSON, as Majma is saying, and then you decide if it's valid, then do. So for example, a lot of people write code, right? If exists, then do that. So your kind of construct will look like if eJSON, then insert, else don't even insert. Okay. So you can play with your application constructs and code structure like that, whatever is the best fits your one. So this is like if you could get a, for example, I was talking about you want to see how many people have been vaccinated 5 times for COVID in the country, and that data is available with NHS. And how many people have electric vehicles in last 3 years, or etc. If you want to play with this kind of data, they are all available on public sites or government sites in JSON format. You could download that into blob storage and then use the techniques to actually load onto it. JSON document store. Okay, so this is an interesting thought process to think through. If you see the evolution of NoSQL databases over the last few years, the NoSQL databases are nothing but JSON stores. They get JSON data, they store in JSON, and then everything else is the application program's responsibility to find what field I'm looking for, query them, aggregate them, convert them, do everything then, right? So you could do that. You could use SQL as a JSON store. Nobody's stopping you. So JSON data type kind of transcends the space. there is no difference between a SQL database or a NoSQL database. It becomes now Omni database. Now you get the data, store this in JSON, and then do everything you want to do to your heart's content. Okay. One more important scenario for using JSON is that any of you either work in an ISV company or have implemented an ISV software which has to be customized. Okay. So interesting scenario, for example, you buy a off-the-shelf ISV software either for payroll or for sales ordering or inventory management or library books. You do, sorry, you have a question? Oh, you have that, okay, good, awesome. So when you buy that kind of software, this software is usually kind of standardized, right? But you have a unique scenario, and you want to add a column to it, or you want to do something special, and there, having a JSON data type helps, because now you can add all your customization as part of that JSON data type at the end of the table, and you can add all this new extra functionality that you do. And a lot of ISVs are trying to explore that path. Okay. So with that, I have a call to action for you. JSON data type is available as a private preview today in Azure SQL database. Please go explore it. This link will take you to the private preview site. The whole blog is written there, and then we have a sign up sheet also. You can sign up to get access. Very soon it will be public preview, so you can get access to any Azure SQL database as well. And then based on your feedback, we will carve the path for GA. And so please do that. So the sooner we get the feedback, the sooner we can take it to GA. Sooner we take it to GA, the sooner we can bring it to the next version of SQL Server. So it's a distributed responsibility, joint responsibility for us to make it the full path. It has got all these capabilities on top of everything else that I talked about that we had introduced in previous versions, like OpenJSON and stuff like that. So yeah, please take a note of the link. That's the link that all you need. It has got link to the documentation, examples, samples, everything. And with that, the change of scenario. On public demand, we are introducing what we call is regular expressions into SQL. Regular expression that has been there for in many programming languages, in many kind of stuff, but we are bringing it into SQL. So with that, let me introduce my colleague Abhiman, and he will walk you through the path of how regular these regular expressions are.
Thank you, Sanjay. Just a quick poll. How many of you are using regular expression in any of your applications or ever interacted with the regular expression in your life? That's quite a lot. I mean, almost everyone. Yes, you are right. So if you go to any portal and you put in your email ID or maybe phone number, or for that matter, credit card or PIN code or any information, the validation which happens is through regex. So it gives you the flexibility to match the regex pattern. Based on the complex pattern, you can match and also fetch the data. Regex also enables you to manipulate the data, and at the same time, you can extract the data. So it gives you the flexibility that even if you have a complex scenario and the larger data, you will be able to match your pattern and fetch the required data, whatever you're looking for. And as I said, it improves the data validation. So no matter any application, any library, or any service you go to, I'm sure a majority of them would be running on the regex behind the scene. And it also gives you the option and the flexibility to transform the data, clean up your data, and make your data in a standardized format. So let's say you have some inconsistency in the data, or maybe unwanted space or incorrectness, you will be able to fix them as well with the help of regex. So moving on to the regex support, how it's looked like in Azure SQL DB. So regex support in Azure SQL DB follows POSIX standard. like any other regex library out there in the market. Yeah, we all know that SQL conventionally follow the ANSI standard, which recommends the X query. But if you look at any library, could be PCRE, could be Golang or CSAP or any other library, all the regex implementations are covered and based out of POSIX standard. So let's say you have an application. In your application, you have some validation or some logic written in the regex. You will be able to use the same regex pattern now in your Azure SQL database with no or minimal change. And yeah, it does support case sensitivity. It does support character classes, quantifiers, anchors, and the subgroups. So everything is covered. So with the help of regex pattern, in your regular SQL query, you will be able to do complex pattern matching and perform more powerful search operations. It's going to be available in private preview, as Sanjay said, starting April. And it will be available across all the tiers of Azure SQL DB. So these are the functions which we are introducing as part of our regex private preview. regexp like if you want to match some pattern, regexp count if you want to find the number of occurrences of your match in the string, regexp instr if you want to find the position of your match, replace, as the name suggests, if you want to replace something based on the regex pattern, and the substring if you want to find the substring out of your larger string. So I'll move ahead and show you the demo, how it works actually in the native implementation in Azure SQL DB. Okay. So as you see on the screen, I'm not sure if it's readable. regexp like, you can use it if you have, let's say, a string and some pattern, and based on the pattern, if you want to know whether it's a true or false, I mean, if the match is found, it will return true. If not, then it will return false. Similarly, if you have a larger string, and based on the regex pattern, you want to count the number of occurrences of your match, you are covered with the regexp count. With the regexp instr, you will be able to find the position of your match that could be either starting position or ending position based on your parameters. You also get a flexibility to define if you want to start your match from the first match or from the nth match. Again, in the regexp replace, you also get this opportunity to define from which place you want to start finding, and based on the match, you can replace it. In the substring, again, you can find the substring. So here, in this example, I'm creating an employees table, and in this table, I'm inserting a couple of records. And if you take a closer look, couple of emails are not right. Those emails are not right. I mean, the second and third one, if you see, that's ls@fabricam@com, and again, the third one, bob.fabricam.net. Those are not the valid email address. Again, if you look at the phone number, they are also not in consistent format, but I'm doing it. So we'll go ahead and run this. And then we'll use the regex functions to show you how you can use your regex pattern to filter out and fetch those results. Okay, so here you go. I have executed the query. You can see all these 5 records inserted. If you take a closer look on the second and third row, those email addresses are not right. Now, I am writing my query to filter out the email addresses which are correct and also ending with a .com. So I don't want email addresses which are ending with a .net or .co.in or anything else. I'm just looking for the email addresses which are valid and ending with a .com. So I'm using regexp like function here. As you can see, I'll go ahead and run this. And it's returning 2 results. technically there are 3 email addresses ending with a .com, but one got filtered out because that email address is not correct. Similarly, now I have a requirement to count how many valid email addresses I have in my database. So you got it covered with a regexp count. So I'll use regexp count here to find the number of valid email addresses I have in my database. So I'm using the regex pattern, which will filter out the correct email addresses, and it's returning 3. So I have a total 3 correct email addresses. Now I want to know how many of those email addresses are for the outlook.com, or could be the live or hotmail. Based on the subdomains, I want to filter them out. Because if I have a huge data, I want to know how many signups are coming from specific domains. You can also do that the way I'm showing here in my example. So this will fetch it. We have 2 results ending with a contoso.com. And one with a .co.in. Let me scroll it. Yeah, so as you can see, one with a contoso.co.in, and we have 2 email IDs with a contoso.com. You can do these kind of operations. So now I'll go ahead and recreate the table, because Sanjay asked me, you are able to filter out the unwanted data, but what if I don't want to let users insert any incorrect data itself in the database in the first place? So I promised Sanjay that yes, we are covered. So now I'm creating the same table with the same number of columns, but for a change I'm putting check constraint on the email and the phone number columns. So I want to make sure that any data coming in should have this format for the email and this standard for the phone number. So phone number should be in 3-digit hyphen 3-digit hyphen 4 digits. An email ID should be valid email address. So I'll go ahead and create this table with these 2 check constraints, because they are going to validate any incoming data. So since I'm putting check constraint, the data which I'm inserting here are in correct format, otherwise it won't let us insert this. So let's go ahead and run this. Yep, so the query executed, and as you can see, we have inserted 5 records. All the email IDs and phone number are in the desired format as we wanted to. But also to prove, Sanjay, that yes, it's working behind the system, not just I have inserted the right data here, let's validate. So here in the next example, I am inserting a data which is not in the right format. Demo@contoso@com. And if you look at the phone number also closely, we have 3-digit hyphen 3-digit, but the next hyphen is replaced with the underscore. So this both the data, email ID and phone number is not correct. So ideally, database shouldn't allow this row to go and get into. Let's see. So as expected, it's failing with a conflict and complaining about the email address. Yeah, there you see the cursor. It's complaining. So let's go ahead and fix the email address. And I'll go ahead and try my luck if it goes through. What if the phone number one is not working? And let's see. Yeah. This time if you see, email ID is corrected now, but now it's complaining about the phone number. I'll go ahead and fix the phone number also in the format I wanted to, and we'll run this. Yeah, I got the record inserted. And just to validate, I can just go ahead and run select star from the employees table, and we can see this record should be inserted successfully in the table. Yeah, here you go. The record got inserted. So if you don't want any incorrect data to be inserted in your database in the first place, you can use this as a check constraint. You can put the domain integrity on top of your table. So we'll move next to the next function, that is regexp instr. So if you want to find the position of the match of your regex pattern in the larger string, And that could be the first match, or could be the nth match, or the last match. You can do that based on this. But in this example, I'm trying to find the position of @ in the email address. So if you look at this, select name, email, and I'm using regexp instr for the email column. In my regex pattern, I have @, and it will give me the position. If you see, for the first email address, I got 5th position. For the second, I have 6th, because that's a Alice. 4th for the Bob, likewise. So we'll use the regex p replace now. Regex p replace you can use for any scenario wherein, based on some complex pattern, you want to replace something in your data. You can do that. So here in this example, I'm changing the format of the phone number the way it is stored. I had 3-digit, -3-digit, -4-digit. Now I want initial 3-digit to be within the bracket. And in the second column, I'm masking the last 4-digit. Could be any other requirement as well, but just to show it here, I'm just masking the last 4-digit of the phone number based on the regex pattern. So if you look at my regexp pattern, I'm saying for the first subgroup, put the number in the bracket, and the remaining 2, the second and third subgroup, leave it as it is. So yeah, let's go ahead and run this. Yeah. So if you take a look at the result, my previous phone number was in the first column. I changed them to another standard format as I wanted to. I mean, putting them first 3 characters in the bracket, and in the second example, I masked the last 4 numbers. So the last function, regexp substring, here I am trying to find the substring from my larger string. So in this example, I'll find the domain of all the email addresses what I have in my table. So based on the regex pattern, I'm trying to find whatever I have after the @ in the email address. So I'll go ahead and run this. Yeah, so as you can see, we are able to fetch the domain of all the email address, right, from first to the last. We see control. So you might have a requirement to find any substring from the larger string based on the regex pattern. You can do that. So these are the 5 functions we are introducing as part of regex private preview. Any one of you have any use case which you feel is covered with these functions or not covered, or any question you might have? Yes, please. Mm-hmm. Yep, good question. So you will also, yeah, the question is, will I be able to use the index as I can use on the like, and how performant the regex implementation would be? So yes, you will be able to create a computed column using the regex function and put an index on top of that. So you'll be able to use the index. And in terms of performance, we have fine-tuned our implementation. Again, it's a private preview. We'll be using with a diverse workload to see how it's performing compared to the like function what we have, but it should be pretty good in terms of performance, because we are natively integrated in the engine itself. We are not dependent in any external library or any external bridge or connection. It's right within the engine. Any other question? Yeah, please. You're talking about the SQL CLR libraries, which any users are using, hosting them themselves. Oh, okay. Okay, good. So the question is, if any bug comes in the regex library, how are we going to handle them? So we have a very diverse test coverage in the first place to skim through and go through and pen test to make sure that we are not leaving any bug as is. All the corners are covered. But if we encounter anything, we must encounter them in our test and QA environment first before going on a production, because cloud, as you know, all the database resources are shared, so we are making sure that it's bug proof. But if you find anything, yeah, just please let us know. We'll be happy to know.
Okay. So the question is about the indexing in JSON data type. Is there the question? Okay. It's on our roadmap. Okay. So as Mojma says, she runs the team. So the indexing for JSON data type is on our roadmap.
I think the other part you're saying is about constraint, right? You said something about the constraint. No, okay.
All constraints are solved.
Yes.
So only constraint is to make sure that whatever the roadmap gets done. So good. Thank you.
Yes, sir, please. Mm-hmm. Yep. So the moment you sign up, there's a team who will make sure that you have a valid NDA signed and all those formalities. Then they'll onboard you. Once you are onboarded, you will be able to try out. So I would recommend you all to go ahead and sign up to experience the function before anyone else. And yeah, share your feedback, run your workload, try out how it works. Yep, sir, please. Okay, so the question is it going to be available on a SQL MI? So the answer is not now. In the first place, we are going to announce and make it available on Azure SQL database, but in future, it's going to be available on MI as well.
So to add to that, these are core engine capabilities. They are not dependent on the deployment model. It is just our path to easily roll out into where we do. So very soon it will be available in Azure SQL Management as well, and then following in the next version.
In the vNext, of course.
So it's just a matter of staging for us. Yeah. Do you use SQL Management instance? Okay. Yeah, so the thing is that a good part is that you can just spin up a SQL database and play with it, and then if you're comfortable, give us. Your validation will also be an influencer to us how soon we enable it in SQL Management instance. So let's say you use it in preview and then tell us that, yeah, this preview is great for me, functionally great for me, but I want it on a SQL Management instance. So that can expedite our path.
Yeah. Any other question? Please.
No, so the question is the space. If JSON is stored as a native JSON data type versus JSON is stored as a text, which is more space efficient. So storage space point of view, there is not much different. Mojma, correct me if I'm wrong.
Yep.
So the difference comes in the operations on it, because when stored in the binary format, all of its operations become super efficient, because finding a component from there, parsing it, doing everything, but they become super efficient. So you as a developer and the subsequent performance of your app is much superior compared to if it was as a text. And also you as a developer, you don't have to kind of we cannot do that kind of find an element from there or find this thing from there without kind of doing a substringing. So that's the reason we are going to a native storage in a binary format.
All right.
Good.
So we have a feedback for the entire dev community. If you have any request, any feedback, or maybe a request for a feature, you can go ahead and submit a request here. We'll go through it, we'll talk to you, and we'll work on them.
So your feature request on something be next version of SQL Server, or your feature request was something in Azure SQL Management, all can go there.
Yep.
every single bit actually helps.
Anything from the entire developer
your
community.
feedback helps us to prioritize things, how we roll it out.
Yes.
So, so please use that medium to kind of influence us. Thank you all.
Thank you.